sensor. My name is Tommy.
My name is Duong Swami.
And the purpose of our project is we wanted to do something with like a proximity sensor, and we just decided to do something to assist in like parallel parking or backing up.
Our original idea was to actually use a real car, but for demoing purposes, we decided to put it on a script. So over here we have our schematic, and we're using a 9-volt battery-powered Arduino, and we're also using an ultrasonic sensor to detect if an object is in front of the car or behind the car. It does this basically by sending out pulses, and then in our code we have a code that converts the microseconds it takes to get from the sensor to the object into distance in centimeters. And on the side we have a piezo buzzer and LED that works simultaneously, and it works so as it gets closer and closer to another car, it starts beeping faster and faster. And on the LCD we have it displaying the distance between the object and the sensor.
This is the timing diagram of how the sensor works. Pretty much we have to send a trigger pulse just to turn it on. We send like a 10 microsecond pulse, and then that's gonna turn it on. It's gonna start sending out some waves, and then that's gonna make the echo pin turn high. So in order to get the distance, the echo pin will turn high, and then once it gets reflected back, like once the sound wave gets reflected back, the echo pin turns low, and then you want to start a timer and it turns high, and then you turn off the timer once it comes back, in order to get the timer. And then the way we did this was we used a polling method. We tried a couple of different methods, but polling just worked the best for us. We start the timer once the echo pin turns high, and we started a count. And the count for us was for every count it increased, it was about 1.5 microseconds. And then once you get that, we wanted it in centimeters, so we used it's 343 meters per second, so we converted that to centimeters. So we divide that by the time it took for it to come back, or for it to go out and then come back, and then we divide it by 2 because that's twice the distance for it to go there and back. So we only want the distance for it for one way.
And for the LED blinking and piezo buzzer, we use a timer and interrupt in CTC mode. And basically, we kept the frequency the same and changed the duty cycle from 2% to 100% for that one.
And then we had to put a software delay in it. If you trigger the sensor too quickly, it becomes very inaccurate because it tries to send out too many pulses, and it gets confused at which pulse is going out and which pulse is going in. We just did a pretty big number, but you could calculate. You pretty much just need enough time for the maximum distance. I think our sensor goes to like 13 feet. So 13 feet, and you can calculate that using the speed of sound. And now, I guess it's time for our demo. Our demo, we just put it on a scribbler that we just programmed to just move forward. And then it's just supposed to, as it moves forward, it's just going to start beeping faster, and the LED will start beeping faster.
So the max distance, we set it at 60 centimeters, and right now it's out of range, so it's not going to blink right now. But we also programmed this to just move forward. Wait.
What happened?
Dude, I think the mouse got loose.
It's just not working. Oh wait, yeah, it's on. It's on.
It's fine.
What's on the
Yeah.
LCD?
Huh?
What's
Oh,
on
on
the
the
LCD?
LCD it displays the distance between
Yeah, so it's just
between
like
this
60
box and
centimeters.
this.
And
It's
then
shown.
if it's out of range, it says out of range. Because we only
You said that.
capped it at 60 centimeters.
Do you wanna take a look?
Yeah, let's zoom in.
So
Beautiful, thank you.